For part 2 of binomial distributions, we're going to discuss how to calculate a binomial probability on our calculator. To problem 14.26, roulette betting on red. A roulette wheel has 38 slots, so 38 outcomes, numbered 0, 0, 0, and 1 to 36. The slots 0 and 0, 0 are colored green, 18 of the others are red, and 18 are black. The dealer spins the wheel and at the same time rolls a small ball along the wheel in the opposite direction. The wheel is carefully balanced so that the ball is equally likely to land in any slot when the wheel slows. Gamblers can bet on various combinations of numbers and colors. If you bet on red, you win if the ball lands in a red slot. What is the probability of winning with the bet on red? So probability of winning with red is number of ways that you can get red versus the number of outcomes. So we have 18 red out of 38 slots total. 18 divided by 38 is equal to 0.4737. The next question says, you decide to play roulette 4 times. So now we have a set number. Each time betting on red, what is the distribution of x, the number of times you win? Thinking about this, we want to check our distribution and see if it meets the categories for binomial. It is binary, as you're talking about either being red or not red, so that's a success failure. It is independent, as each of the trials are independent. The first trial landing on red or not red does not determine what the next trial will be. It doesn't have any factor or influence. There is a set number of trials for 4, and the probability of red remains the same. We don't remove a piece of the roulette wheel and change it from 38 outcomes once we land on red. This is a binomial setting, and the distribution of x, the number of times you win, is binomial with n equals 4. And p equals 0.4737. Part C says if you bet the same amount on each play and win on exactly 2 of the 4 plays, then you will break even. What is the probability that you will break even? The probability that you will break even is the same thing as if you were to get 2 exact. Well, there's not just one way to get 2 exact. I could get the first and the second, the first and the third, first and the fourth. There's a variety, so we want to use that binomial coefficient. This is equal to the probability of x equaling 2. So if I wanted to use the binomial formula, that looks like n, which is 4, choose 2, the probability of success, which is 0.4737, to the second power because we want exactly 2, and then 1 minus the probability of success, to the n minus however many we're choosing, which is 4 minus 2. We could plug this into our calculator by pressing second vars for distributions, and we want to scroll down, and because this is one exact value, we want a binomial PDF. In our binomial PDF, we have 4 trials. The probability of success is 0.4737. The x value that we want is 2. Hit enter, and our probability is 0.3729. This matches if I was to say 4, choose 2, times my probability of success to the second power times 1 minus my probability of success. Oops, too many in there. also to the second. So they're exactly the same value. Part D says, if you win fewer than 2 of the 4 plays, then you will lose money. Fewer than 2 is equal to the probability of having none plus the probability of having 1. So I could repeat the same process that I did in C with x equals 0 and x equals 1 and then just add them. Or I could do a binomial PDF from 1 down. This is equal to the probability that x is less than or equal to 1, which is also equal to the probability that x is less than 2. So let me show that to you. We'd go to our distributions. I'm going to up arrow to get us to binomial faster. Oop, not Poisson. Okay. Let's try this again. We'll quit. My calculator is pretending that it's possessed. Okay. The number of trials was 4. The probability constant was 0.4737. The x value is 1, and I'm going to paste it, which is 0.3529. Now, you'll notice that the question said fewer than 2, and I entered 1. The reason is the binomial in the calculator does from the value you're speaking of down, so I needed to do from 1 to 0. If the value that I want is not to be included, I start at the next lower value. Okay? So if I wanted the probability of being greater than 1, that's equal to 1 minus the probability of being less than 0. So there's a couple of different ways that you need to think about the notation. On the calculator, it always does from the lowest value down, never does up, so we need to use the complement. Greater than 1 is less than or equal to, actually less than or equal to 1 is probably what I wanted. Whoop. That's what I meant. So in my calculator, I would do 1 minus this value. So you need to remember that the calculator does from the value you want down. So if you don't want to include the value, don't include it in your calculations. And that's it for binomial calculations.